All right, today we're going to learn about points of concurrency, and we're going to delve more into this on Monday and Tuesday of next week, but make sure you take all these notes so that we're all on the same page come Monday. So points of concurrency, it's all about this idea that whenever we have three or more lines that intersect at a single point, so three lines all intersecting at one point, they are said to be concurrent. Hence the points of concurrency. Right, they're said to be concurrent. And in any triangle, there are going to be 4 points of concurrency that we can find. First being the circumcenter. And if I kind of look at this picture and observe these 3 lines that are all intersecting at this point O, I can see that each of them is perpendicular to its kind of respective side. So like this one is perpendicular to XY, this is perpendicular to YZ, this one's perpendicular to XZ. And also each of these 3 lines splits the side in half or bisects it. So if we've got perpendicular and bisects, what do we have? Perpendicular bisectors. So the circumcenter is the intersection of the 3 perpendicular bisectors of the sides of the triangle. So if I take any triangle, do the perpendicular bisector of each side, they should meet at a single point called the circumcenter. Second one is called the incenter. And if you see, these lines seem to be originating from each vertex of the triangle, and it's splitting each of these angles in half. So this is the intersection of 3 angle bisectors of the vertices of a triangle. And I'm realizing we should have an S here, perpendicular bisectors of the sides. So we've got perpendicular bisectors, angle bisectors. Moving along, we have an orthocenter. Well, an orthocenter, you may have figured out by the bolded word towards the bottom, is the intersection of what we call altitudes. So an altitude, you can maybe kind of see it in the picture. These are lines that are perpendicular, but doesn't necessarily bisect, right? I don't have these congruent markings. So an altitude of a triangle is a perpendicular line segment from any vertex to the opposite side of a triangle. So if I take this vertex and go drop a perpendicular line to its opposite side, I get an altitude. 3 altitudes meet at an orthocenter. And finally, we have something called a centroid, which is the intersection of the 3 medians of a triangle. Another new word. And it's also it's often referred to as the center of gravity of the circle, which I will explain more on Monday. So a median is a segment, right? And you can kind of see it here, that joins the midpoint of a side. So if you know the midpoint, to the opposite vertex. All right, so like for instance, this is the midpoint of this side, and I connect it to the opposite vertex. Midpoint of this side connected to opposite vertex, right? So on and so forth, midpoint to vertex. That's a median. 3 medians meet at a centroid. Okay. So what we'll be doing on Monday is learning how to construct the circumcenter and incenter. You're really only going to need to know what the orthocenter and centroid are. We might deal more with centroids towards the very end of the year. But for right now, we need to kind of review, well, how do I construct a perpendicular bisector? How do I construct an angle bisector? Because that's going to be helpful on Monday. So let's do that. Perpendicular bisector. If I wanted to find the perpendicular bisector of the segment joined by these 2 points, step 1, connect the points. And if you want to, feel free to pause this, grab a piece of paper, and kind of follow along if you have a compass. Otherwise, we'll be able to practice these on Monday. So if I have my segment, you may remember how to do the perpendicular bisector. This is when we did the fish shapes or football shapes. So we start at one end, one vertex, okay? And you have to make sure that your compass is set to be more than halfway. And I can draw my one fish shape. come to the other vertex, kind of in this case, other endpoint, sorry, better word, and draw the other half of my fish. And then I can connect these 2 points, right? And this is my perpendicular bisector. So this pink segment, if I make it a little bit longer, is my perpendicular bisector. So it would meet at a 90-degree angle, and it would cut this segment exactly in half. And something that we talked about, if you remember, I proposed the problem of I want to live between a Maggiano's and a Chipotle, and we figured out that actually any point on this perpendicular bisector is equidistant from the 2 endpoints. So that's kind of our recall. All points on a perpendicular bisector are equidistant from the 2 endpoints of the line segment. So if I were to pick this point, for instance, whoops, right? If I were to pick this point and I were to connect, right, this distance here would be the same as this distance here, right? Those 2 black dotted segments would be equal, making an isosceles triangle. All right, the second one I want to review is an angle bisector. And so I have an angle here, and I want to bisect this angle. So I'm going to first put the compass on the vertex of the angle and draw an arc. Does not matter where this arc gets drawn. It just has to go through both legs of the angle. And then I'm going to keep my compass the same. You don't actually have to, but easier that way. I'm going to move it up to this first intersection point, and I'm going to make an arc in the middle of the angle. And then I'm going to move it to the other intersection point, and I'm going to make an X the other way. All right, and this should form an X in the middle of your angle. And so if I connect the vertex of the angle and that point, I will get my angle bisector. So that line splits this angle perfectly in half. And our recall for this one is that any point on an angle bisector is equidistant from the 2 legs of the angle. So if I take this point here, and I were to draw the distance to this line, which has to be a perpendicular distance. So if I go straight down, and if I were to be able to do this on this side, which is going to be a little bit harder because it's at an angle, but if I were to be able to draw a distance so that this is also a 90-degree angle, again, these 2 dotted black line segments would be equal in length. So, Miss Averill, how would you draw such a perpendicular line? Glad you asked. Final thing, how do you draw a perpendicular line through an external point? Well, I got to make me a segment where this point is equidistant from both endpoints, and then I can use the perpendicular bisector. So I'm going to extend my compass from the point a little past this line, draw a little arc. And so now you would agree, based on how I did this, that this segment is in fact a segment such that this point is the same distance away from this top point, right? My 2 orange dots are the same distance away from this one. So if now I do the perpendicular bisector of this new little segment, right? So draw my fish, and over here, and draw my fish, and connect them, I will get a perpendicular line through this point. So this line is now perpendicular and goes through this external point. So if you need to rewatch those constructions to make sure that you have them down, feel free to do that. These are all what you're going to be needing on Monday, and that is your intro to points of concurrency.